Okay, this is week 6, lesson 6. This is the sum of a geometric series. So, in other words, you have a list of numbers that have a geometric pattern, meaning to get from one number to the next, you're either multiplying or dividing, and this formula will help you add them up. All right, so let's write the formula. S sub n is equal to the first term times 1 minus r raised to the n over 1 minus r. Now, for the first example, this should come out fairly okay. They've given you everything you need. I know the first term, 1 minus the ratio raised to the n over 1 minus r. Okay, so let's see. This is going to be 3 times 1 minus 32 over, oh, and I forgot to plug in that r, over 1 minus 2. All right, so the sum of the first 5 is going to be 3 times negative 31 over, and I still forgot to put in the r. 1 minus 2 is negative 1. So let's see, the sum of the first 5, again, handy dandy calculator, I believe this is 93. All right, now you know, because of a lesson a couple sections back, how to do this in your calculator, and I love that. And if you want to put it into your calculator, you should get 1.98. But please be able to show your work, right? If I ask you, let's say on a Schoology assignment, to upload your work, and you just say, I did this on the calculator, you know I'm not going to give you the credit. So let's start plugging in some numbers and see what happens here, all right? Maybe even only 3 of them. So when I plug in 1, I get 1. When I plug in 2, I get 1/2. When I plug in 3, I get 1/4. All right, and it's pretty obvious that this is geometric with a first term of 1 and a ratio of 1/2. Okay, I also know that I'm trying to find the sum of the first 7. So here we go. In the formula, the sum of the first 7 is going to be the first term times 1 minus the ratio raised to that same number, the same n, over 1 minus 1/2. Let's see. This denominator becomes 1/2, so 1 divided by 1/2 becomes a 2, and then this is 1 minus 0.5 to the 7th. Putting that in your calculator, you should get that 1.98. Okay, so this is asking you to find 2 different geometric series where if you add the first 2 terms, you get 20, and if you add the first 4 terms, you get 1640. Now, the way that can happen is with different first terms and with different ratios. So let's kind of think about this and how we know this. All right, so the sum of the first 2 terms, I would have to add the first term to the first term times r. In other words, if I factor out a u sub 1, this would be 1 plus r. And I know the sum of the first 2, right? It's 20. So 20 is equal to u sub 1 times 1 plus r. Okay, so then using the formula, all right, the sum of the first 4 terms, there's a formula. It's at the top of the page. You can turn it over and take a look at it, but it's the first term times 1 minus r to the 4th over 1 minus r. Okay, and actually I know what the sum of the first 4 is. It's given to me right here. So 1640 equals u sub 1, and I'm going to simplify this by factoring. All right, so this term is a difference of squares. 1 plus r squared, 1 minus r squared over 1 minus r, and this, believe it or not, is still factorable. So continuing, I end up with 1640 equal to u sub 1 times 1 plus r squared times 1 plus r times 1 minus r all over 1 minus r. So now this cancels with this. Okay, so now here's where your mind is going to be blown. You need to set this up as a ratio. Let me tell you what I mean. So 1640 divided by 20 should be the same as this u sub 1, 1 plus r squared times 1 plus r divided by this. Okay, which is really cool because now the u sub 1's cancel, the 1 plus r's cancel. This reduces to be 82, and I get 1 plus r squared. So simplifying this, 81 is r squared, or in other words, r is equal to plus or minus 9. Okay, so the ratio could be plus or minus 9. Okay, so now let me go back to the first number that I know, which is the sum of the first two terms. In fact, let me kind of go back up here and highlight what I'm using. I am using this. Okay, so using that, let me put in some numbers. So I'm going to have 20 equal to u sub 1 times 1 plus 9. This is for the situation where r equals 9. And I end up with the first term equaling 2. In other words, the whole formula here is going to be the first term times the ratio raised to the n minus 1. Now there's the other situation, that should be an r, where r equals negative 9. And if I use that same formula, u sub 1 plus negative 9, I end up with a u sub 1 of negative 5 halves. So my other formula is negative 5 halves, a ratio of negative 9 raised to the n minus 1. Okay, and then this last problem, this is similar. We did a problem like this recently. My paper had a typo. This should now more closely resemble, actually not exactly resemble. Let me see if I can fix this. On your paper, it should say 7 to the n minus 1, like this. That minus 1 shouldn't be the exponent. Okay, so here we go. If this is saying that there's some numbers that are in this list that we are adding up. When I plug in 1, I should get the sum of the first term. So when I plug in 1 into that equation, I get 6, which means that the first term is 6. Okay, when I plug in 2 into that formula, I get 48, right? It's 49 minus 1, which means that these two numbers should add up to be 48, which means that the second number right here has to be 42. Once you know first two numbers, then I know what the common ratio is, right? What do I multiply by here? I would have to multiply by 7.